Before we get into Gauss's law, we have to be very solid on a mathematical concept. We have to have it inherent. We have to have it something that you don't even, just comes to you completely naturally. So important for the rest of the class is vector flux. Okay? Our simple definition of vector flux is how much a vector field goes through a surface. Goes through a surface. I can begin to draw it like this. So say we have a vector field. Let's not even worry about what it is. E field, B field, doesn't matter. Any vector field. Let's draw our vector field as a uniform field, as we talked about before. Just everywhere you go, it's a field pointing that way with the same magnitude. And then let's draw a surface. So here I'll do kind of a little oval, kind of in the plane of the board, kind of like that. Or not in the plane of the board, kind of to the side. And you have to think about the vectors going through the surface. This is so important to have this down in your head. We are definitely going to go do this in the visualization lab so we can get a look at it. So it's critical to understand that everywhere you go in 3 dimensions, there's a vector field this way, and that this is really a little hoop that's pointing kind of like this, and the field vectors are going through the hoop. Okay? You've got to be able to see that to understand vector flux. So when you say how much, you just say, well, I don't know, maybe 2 would fit through there. So let's think about how we decide how to figure out what the vector flux is. It really depends on 3 things. It depends on the field magnitude. Okay? So if it's a really weak field that I draw here, then of course it's a smaller flux. If it's a really large field, it's a bigger flux. So you would expect that it depends on the field magnitude. It depends on the area of the surface. And that also seems to make sense. Big area, more field's going to get through. A little area, less field's going to get through. So it depends on this magnitude. But there's one more thing it depends on, is it depends on the angle of the surface. So if you think about it, if this thing is sitting up like this, lots of field vectors get through. If you turn it, the amount of field going through is going to go down. So let's look at that a little bit more carefully.